A stone is dropped into a lake, creating a circular ripple that travels outward at a speed of 60 centimeters per second. We want to find the rate at which the area within the circle is increasing after A, 1 second, B, 3 seconds, and 5 seconds. And then what can you conclude? Okay, well first, what we need to talk about is the fact that the ripple is traveling at 60 centimeters per second. So the ripple is traveling at 60 centimeters per second. Okay, and then we also know that what does the radius equal here? Well, the radius is equal to the rate of travel times time. So that means that we have the rate of travel, which is 60 centimeters, and we're going to multiply it by time, which we know is t. So therefore, the radius is going to be 60t. Okay, and then we also need to determine what is the area of a circle. We know the area of a circle is pi r squared. So we're going to substitute r to be 60t. So we're going to have pi times 60t, and then we're going to square it. So therefore, when we square that, we get 3600 pi t squared. So now what happens is that the area now becomes a function of time. So we have a of t now, which is going to equal 3600 pi t squared. And again, we can say that area is now a function of time. Okay, so before we proceed, we need to find the rate at which the area within the circle is increasing, meaning that we need to find the instantaneous rate. So we have to find the derivative of this area according to a function of time. So a prime of t is going to equal 2 times 3600, which becomes 7200 and then pi t. So now that we have our derivative, now we can find out what is the area at 1 second. So for a, we want to find out when t is equal to 1 second. So we want to find a prime of 1, which is equal to 7200 pi times 1. So therefore, that's going to equal 7200 pi, and that is centimeters squared per second. Okay, and then we want to find b when t is equal to 3 seconds. So we want to find a prime of 3, which is equal to 7200 pi times 3, which then gives us 21,600 centimeters squared per second. And then when we look at part C, we want to let t equal 5 seconds. So we want to find a prime of 5, which is equal to 7200 pi times 5. And that gives us 36,000 pi centimeters squared per second. So what we want to say, okay, what's happening here? So when it's 1 second, it goes to 7200 pi centimeters squared per second, and then 21,600, and then 36,000. Okay, so what can we conclude? Well, we can conclude from this is that as time goes by, the area grows at an increasing rate. And in fact, the rate of change is linear with respect to time.